Hello, my name is Irvi Chakraborty and this is my Lab 2 Lines of Charge presentation. In the previous lab, we had two lengths of tape that we had to float on top of one another. We had to measure various different numbers, including the length of the tape, the mass of tape, distance between each tape while they are floating above one another, and with these few numbers over here, we had to calculate gravitational force, electric force, and the charge on tape B, or just one of the tapes above or below. In this lab, most of the procedures will be the same, but now we'll have a more accurate computational model of a line of charge instead of a point charge representing the charge on the tape that we will be calculating through GlowScript. This charge will be evenly distributed across the length of the tape, as opposed to being on the single point over here that's represented on the picture on the right. Now let's discuss the code and the models that we use to calculate the charge on each tape. Over here on the left, you see the model that was made through VPython. The white arrow represents the electric force between the tapes, and the yellow represents the gravitational force that's pulling the tapes down. Over here for this model, we had to assume that we had to ignore air resistance. We had to make sure that the U tape has the same amount of evenly distributed charges, and the mass of each tape is 0.0002 kilograms. The key concepts that we used in this model was electric fields, electric forces, gravitational forces, and the sum of forces. We have our standard equations of the force of electric field equals to EQ, as well as the force of the electric field, the force of gravity, and knowing everything that we do know about the tapes, in order for the tapes to stay on top of one another, the sum of forces has to equal to 0. The procedure that we followed in the code was that first we calculated the gravitational force, we equated the gravitational force to the electric force produced by both tapes to find the magnitude of the electric field, and using the magnitude of the electric field, we solved to find charge Q. Using this, we found that the charge on one tape would be around 3.55 times 10 to the power negative 9. The magnitude of the electric force and the magnitude of the gravitational force are equivalent, but they are opposite, since the electric force would be pointing upwards and the gravitational force would be pointing downwards. As some additional observation questions, we had to compare the value of the point charge and the value of the line charge. So using the point charge model, we found that the value was many magnitudes smaller than the line charge value of 3.55 times 10 to the power negative 9. When I first used the charge found in Lab 1, the magnitudes of the electric forces and the gravitational force was very different from each other. I had to adjust and increase the value of Q in the code until the gravitational force and electric forces were equal and opposite to one another. These two values were different because the line charge value better represents the physical phenomenon of the tapes that were actually taking place. The point charge model represents a more generalized version of the actual events. This line charge accurately represents what is happening when the tapes are on top of one another, while the point charge is a little bit more simplified. All right, that's all for now. Thank you.